quicksort is a sorting algorithm used to sort unsorted arrays. For example, this is an unsorted array with 7 elements, and using quicksort, our goal is to sort the array into something like this, where each element is arranged in ascending order. So the smallest is at the start and the largest is at the end. So this is how the quicksort function looks. It takes 3 arguments. The first one is going to be the array itself, the second one is a left pointer, and the third one is a right pointer. Now the left and right variables, these are going to be indices inside the array, which is going to tell us what part of the array we have to sort. For example, if the left pointer was at the start of the array and the right pointer was at the end, then we would have to sort the entire array. But if, let's say, the left pointer was over here and the right pointer was over here, then in that case we are going to sort only this part of the array. So to sort the entire array, we'll just plug in the start of the array as the left and the end of the array as the right. Now before doing anything, we have one condition to satisfy, which is the left pointer always has to be less than the right pointer. Now the reason for this is, if let's say if the left and right pointer were both on the same element, so for example let's say that element is 0 right over here, then the region that we have to sort will only have one element, which is sorted by default. And if the left pointer was right over here and the right pointer was somewhere right over here, then in that case the area that we have to sort would have no elements. So in this condition we are also not going to do anything. But if that isn't the case, then we are going to continue. Now what we do is we perform something known as partition. Now the job of this function is to perform a process known as partition. So let's see how that works. The first thing that this function has to do is it has to choose a pivot. Now there are multiple ways to choose a pivot. For example, you can take the median of the array, the leftmost element, the rightmost element, and there are many other ways to choose the pivot. But for simplicity purposes, we are going to choose the rightmost element as the pivot. So after it chooses the pivot, which in this case is going to be 4, what it does is it arranges all of the elements less than the pivot to the left of the pivot and all the elements greater than the pivot to the right of the pivot. So in this case, the values less than 4 are 1, 2 and 0. So what it will do is it will put these 3 values to the left of 4, and then it will take all the elements greater than the pivot, which is 5, 6 and 7, and it is going to put these values to the right of the pivot, and the pivot will be in the middle of them. So as you can see, it arranged all the values less than the pivot to the left of the pivot right over here, and all the values greater than the pivot to the right of the pivot right over here, and the pivot is in the middle, like so. Now what this function does is it just returns the index of the pivot, which in this case is going to be 3. Then we call the partition function on the left side of the pivot, which is going to be something like this. So from the left, which is the leftmost value at the array, to the pivot -1, which is going to be right over here, then we call it on the right side of the pivot as well. So from here all the way till here, which is going to be pivot +1, which is right over here, till the rightmost value, which is over here. Now what it will do is it will perform partition on these 2 sides as well, and at the end we are going to have a fully sorted array. Now let's see how the partition function actually works. So the partition function will also take 3 arguments: the array, the left pointer and the right pointer. Now the first thing that we have to do is we have to choose a pivot. In this case we are going to choose the leftmost element, which is going to be 4, like so. Then we have 2 pointers. The first pointer is called I and the second pointer is called J. Now most of the time I will be at the left pointer -1, so this is where I will be. Then we run a for loop, and J is going to be the pointer for that for loop, which is going to run from the start of the array till the pivot -1 or r-1. So it is going to loop through the entire array except the pivot. So by default I will be right here and J will be right here. Now we have to check for a condition, which is the value at J less than the pivot? In this case the value is 5 and our pivot is 4. 5 is not less than the pivot, so we are just going to move on. So J will now go right over here. So as you can see, we incremented J by 1 and now J is at this element. Now we are going to check for the condition again. Is the value at the position of J less than the pivot? In this case, yes, 1 is less than the pivot. Then what we do is we increment I by 1. So I is going to come right over here, and then we'll swap the values at I and J. The way we do this in code is something like this. So we replace the value of I with the value of J and the value of J with the value of I. So what this does is it puts the value less than the pivot at the left of the array. So later on all of the values less than the pivot are going to be at the left and all of the values greater will be at the right. Now after repeating this process, we are going to have an array like this. So all of the values less than the pivot are going to come to the left like so, and our I is going to be right here. Our R or the pivot will be right here. Now what we have to do is we have to somehow bring the pivot right over here in the middle. So the way we can do that is by just incrementing I by 1 and then swapping the value at I and the pivot. So that is just going to move this greater value at the position of the pivot, and the pivot will come in the middle. So we are just going to switch the value at I plus 1 with the pivot like so. So we increment I by 1 and then we swap the values. As you can see, we have gotten the index of the pivot. Now this position of the pivot is going to be fixed even after we sort the entire array. So we have successfully sorted one element of the array. Then what we do in the partition function is we return the index of this position so that we can call the partition again on the left side of the pivot and the right side of the pivot. And once it completes those processes as well, we are going to have a fully sorted array like this. Now the only thing that is going to change in code is in here, instead of having this, what we are going to have is a range function like this. So the range will be from R, which is the start of the array, till R, which is the end of the array. Now the reason we don't do R minus 1 is because the range function does not count the last element, meaning if we go from a range of 1 to 10, then it is going to go from 1 to 9. So it already does that for us, meaning we don't have to perform R minus 1, we can just put R and it is going to work the same way. So that is the only thing that is going to change in the code. That was Quicksort. If you enjoyed, don't forget to like the video and subscribe to our channel for more content like this. I'll see you in the next lesson.